Good evening. My name is Bart. I've got here in front of me my assignment for robotics and machine vision. The task was to create a 2 degree of freedom planner robot that would operate on a 20 by 20 grid system, whose boxes, or the grids, which are 30 by 30 millimeters wide, square, sorry. So which means the whole board would be 600 by 600 millimeters. And the robot is meant to be located, which is the base, in one of the 4 corners. So I chose the left bottom corner, and this presentation is what I've tried to sort of like make. So if I won't go into presentation mode, because then I've just saved this I've just saved it as a PDF so I can upload it to the submission portal. So now if I go to the first page, here's just problem definition. The third page is the approach that I took in. So I did conceptualization. I sketched the overall system first and tried to come up with a design, like what I would expect it to, to look like, and things like that, and how it would operate. And then and also it's part of the question to do the simulation, review and improve. So this is this initial sketch that I came up with. So it's a 2-link robot. It would be operating from the left hand corner, and it also mentioned that it would occupy a 3 by 3 space. So that's what it would probably be like. So my robot needs to operate around that 3 by 3 square there. In other words, I should make sure that it doesn't collide with that there, with the base with its base. Sorry, that the end effector doesn't collide with the base. So I went on to link selection, which I used basic trigonometry to calculate the links. Given that I need to cover most of the board, I figured it needed to get to that top corner right there. That would be, yep. So that's how I calculated the links. I just, for the motor selection, I just looked at what's available, what's cheap. JCar was my best bet, because I normally buy all my little toys and stuff from JCar. So that was my first pick. Then I went on to analyze system dynamics. Here I was having difficulties because I think I had digressed from what the question really wanted, but I figured if I'm going to do a motor control, I needed to do the dynamics as well, because then that's where I'd get the torque joints, the inertias, and things like that. So I did the system dynamics. I didn't complete them, but then I just highlighted their necessity in this slide. I then went to do the kinematics. So I focused on the forward kinematics. I talked about the inverse kinematics a little bit. And then here, in this here, I tried to do my first simulation, and it didn't work, but I uploaded the code anyway. The difficulty was that I faced as well was trying to create the robot in MATLAB and simulate it. I went on to the found examples that I could manage to follow, and then I managed to create the robot. In this slide, I have got the code which I actually use for my simulation, and that's it there. I talk about the joint control, and this here is this is motor control. This is the Arduino code for the motor control. It's incomplete, but yeah, that's it there. So I'll just quickly run through my simulation so you can have a look. So I've got MATLAB opened already. There, I just put close all, clear all, because I was running it. If I press run there, and then see at the bottom it's busy, and then we'll see what happens there. There we go. So that's the short video of my simulation there. There's still lots of improvement to be done, because I still haven't gotten my joints quite smooth, and I need to try and focus on how to sort the trajectory so it doesn't blip. I don't know whether it's a graphics thing or not.